Welcome everyone. This is Dr. P. Shyam Sundar, Associate Professor, Department of ECE, KL University. In the previous session, I have explained the operation of an optocoupler or opto isolator. In today's session, let us see the simulation of this opto isolator. Let me open a new file, create a blank one. Let me increase the size for your convenience. MCT2E, when I go here and search for the component MCT2E, I cannot find any component. So if you tell you don't find any component which is required in our database, you can go to net, search for the component and get the component from the internet. So already I have taken the component from the internet and it is saved here. So this is the component which I have taken. I'll just take this component, place it here. Opto isolator is taken now, right? What are the components required? Let me mention the list of components. 1. MCT2E Opto Isolator, one number. Next is we require transistor VC107, one number. Resistors, we require 147 kilo ohm resistor and 100 kilo ohm resistor. Based on the explanation I have given in the previous session, I am recollecting the values of the resistors and providing it here. 220 ohm resistor and 33 ohm resistors, 1.5k resistors. So of these I may require 220 ohm resistors and 33 ohms also I may require two numbers, 1.5k one number, 100k one number. Yes, these are the resistors required. And what else are needed apart from this? VCC and ground are required. These two are mandatory for any circuit. So let us get these components and start connecting the circuit and get the output. Go with the transistors as I have mentioned earlier, BC107. I am taking the transistor over here. Placing it here. Now 47k resistor basic. I'll take the resistance, connect it here. Another resistor, control R, I will place it here. Another resistor, control R, I will place it for RC. Another resistor, I will place it here. Sorry. One more resistor, I will place it here. And I require an LED. Go to diodes. In diodes you can see LEDs here, different types of LEDs. Let me take blue LED. Anything is okay. I'm just choosing blue LED, that's all, right? Now another resistor. I require one more diode, so choose one more LED and place it somewhere on the other side. Go back to resistors. I require one more resistor here, which is 1.5 kilo ohm. Next, one more resistor here, which is RC of the second part of the circuit, and one more resistor here. Right. Now I placed all the resistors required. Now I need VCC and ground. So I'll take VCC power sources. I'll take one ground here. I'll take another ground, place it on the other side. Now I'll take VCC, one VCC on this side and one VCC on the other side. Right. But do remember, if both are denoted as VCC, if you change the value of one VCC, say I change it to 9 volts, the other one also will change to 9 volts. So to avoid that, I'll double click on this. I will label it as VCC1. Click on OK. It will ask, this net has on-page and or global connections. Do you want to change all connected on-page and global connectors, including hidden connectors named VCC to VCC1? No, I just want to change only this. So I'll click on no. Only this is changed to VCC1. Now if I change the value of this to 9 volts, only this will be 9 volts, the other one will not change. Okay, so that is the purpose. I have chosen this as VCC1. Now let us start connecting before it looks clumsy to all of you. As shown earlier, I'm making the connections a little bit fast because I have already explained you how to connect the circuit. And the problem here is this is to be connected to this part only. So what I'll do is I'll just change the connection a little bit slightly. I'll rotate this resistor and connect it over here so that the circuit will be perfect. Right. Now this end of this resistor should go to pin number 1, anode. Pin number 2 should be grounded. Now I have completed one half of the circuit or one part of the circuit. So the value is overlapped by the notation, so I will just move it a little bit. Now on the other side, I will make the connections fast. Now I have connected the other part of the circuit also. With this, I complete connecting the circuit. What is left over is to apply the input. I'll take a function generator. I'll connect it here. Positive of the function generator is connected to R1. Negative is grounded. Now perfectly complete. I completed the circuit. Let me term this as RB. I'll change the label as RB. The value of this is 47K. So let's change the value to 47k, and R2, this one is 100k. Let it be R1. Let me change this to R1. This R3, let us change it to RC. Let us change it to RC1 because there is another RC here. Let us change it to RC1 and the value will be 220 ohms. This is 33 ohms as seen in the previous circuit. Let us term this as R4. Instead of R4, let us term this as R2 and double click on this. Let this be R3 and the value of that we had is 1.5 kilo ohm. On the other end, here let this be 220 ohms with RC2 and let this be R4. R4 value is 33 ohms as we have seen. Right. Now I have changed the values also. Let us see if this circuit works. You can clearly see that the LEDs are blinking here. Alright. LEDs are blinking alternately. When this LED is on, this LED will be off. You can see simultaneously. Right. This is the simulation of Opto Isolator. I told you I have changed the frequency to 1 Hz. Amplitude, sorry, it should be 5 volts peak to peak. I am changing it to 2.5 volts and I am applying a square wave. And now let us run and see. Okay, you can see that the LED is blinking and when this is on, that is off. The other LED2 is off. The most common mistake which may happen here is, since this is MCT2E, you people may connect this to this ground, and if you connect it to this ground, of course the output is coming, but practically the output will not come. When you connect it on a breadboard, the output will not come. LED2 will be continuously glowing. So please keep that in mind. This circuit is to be isolated, right? Thank you.